Currently, most companies are excited about AI agents. But behind the scene, a lot of those agents are either useless, unpredictable, or quietly make bad decisions. If you are a business leader, you probably see this before. Smart agent that sounds confident but give wrong answer. Team wasting time chasing prompts and complex architecture that don't move the needle. The good news, you don't need to be technical to fix this. In this video, I'm going to share 5 lessons from building real AI agent in organization so you can avoid the most expensive mistakes, understand what actually works. My name is Celine Xu. I work as an AI and data strategist in a large global company with more than 11 years experience in machine learning and AI. One of my core missions is to bridge the gap between the business and tech team and leverage AI and data for human-centric decision-making to drive better business results. Let's dive in. Lesson number 1, the legendary prompt myth. We've all seen this. Those perfect prompts being shared online like a cheat code. Just copy and paste and boom. Instant AI magic, right? Not quite. Like most people, I've spent an hour on YouTube collecting prompts from strategy to research to app building. I even built a personal prompt database in my Notion and update regularly. I love good prompt. But here's the hot truth. The same prompt rarely gives the same result. And it definitely doesn't guarantee the behavior you want from your AI agent. Why? 2 key reasons. First, language models are probabilistic, not deterministic. That means even when you feed them the exactly same input, the output can vary. Sometimes it's better, sometimes it's worse. But it's never guaranteed to be the identical. That legendary prompt you copied, it might fall flat when you try it. It's not your fault. It's just how the system works. Second, more structure not equal to more control. Here are most people get tripped up. In traditional software, most structure usually means more stability. But with AI, structured layer adds another layer of uncertainty. Stack too many of those, and your agent become harder, not easier to manage. Here is the real example. I once ran a simple research task using a short, focused prompt. It worked beautifully. Then I tried to replace it with a multi-page, ultra-detailed instruction set I found online, supposedly a best practice. The result? No improvement in quality. Token usage exploded, and the response time slowed to a crawl. Bottom line, copy someone else's prompt won't turn your AI into their agent. So what should you do instead? Stop chasing the perfect prompts. Build a system that learns and adapts. Don't expect your prompt to work perfectly the first time. Iteration beats imitation. Start with the core problem you are solving and apply minimal constraint. Observe how your model agent behaves naturally, then adjust as needed. Use examples instead of rules. Show, don't tell. If your agent can follow your incremental instruction, your system prompt is good enough. Keep it direct, simple, and clear. This is how you move from being a passive prompt copier to a true AI operator. Lesson number 2, the elegant architecture trap. Don't fall into the trap of thinking that copy a perfect architect will give you a perfect system, or your agent performance will automatically improve with complexity. I recently spent days building a research-focused AI agent. Along the way, I came across 2 brilliant articles from Anthropic Agent Design. Inspired. So I decided to put those suggestions and learning into practical copy. I upgrade my architecture, refine my system prompt, add context isolation, build memory, designed what looked like an elegant industry-grade agent system. And the result? Everything got worse. The same task now cost more token. Successful rate dropped. Failures become hard to debug. Some error didn't even make sense anymore. I remember staring at the system thinking, this shouldn't be happen. Am I really bad at this? That moment forced a painful realization. AI agent design is not a traditional software engineering in classical backend development. Start with a robust architecture is usually a safe bet. plan your downstream service, pipelines, maybe slow down at first, but it scales. But AI agent are non-deterministic system. When you stack complexity on top of uncertainty, you are not adding structure, you are multiple chaos. Like many of you, I wanted to follow expert. I assumed this is a complex problem, so I need a complex system. That's what went wrong. There are two types of agent task chain. The first one called workflow chain, which run end-to-end like a traditional process. The second one is called conversational chains, in short, interrupt and segment with feedback loop. Most agents don't need to execute 20 steps in one uninterrupted run. They can pause, confirm, adjust. The meaning, you usually don't give heavyweight orchestration at the start. So here how it works. Start simple. Don't aim for architecture elegance on day one. Focus on core problem. Can the model solve it at all? Choose the path with the highest chance of working, which you know, even if it's ugly. Skip the advanced framework if you don't understand. Establish a baseline that involves. Remember, running something imperfect beats design something perfect that never runs. Lesson number 3. Context collapse is real, and context engineering matters. Have you experienced this scenario? At first, your agent worked well, and then slightly over time, it gets slower, and the performance steadily declined. Then we kept adding things we thought would help. More instruction, more tools, more format, more history, or more just-in-case information. It felt like progress, but the situation not improved. The context collapse. That's what happened when too much information, instruction, and signal mix together, and your AI agent no longer knows what matters the most, which rule apply, and what success looks like. Just like a human employee with 10 managers give conflict direction, the agent gets overwhelmed. Attention gets diluted, accuracy drop, output become inconsistent. It is not model getting worse. It is context. It's context nearing shines. 2 practical tactics. Context isolation and dynamic loading. They are sounds complex, but bear with me. You do not need to execute anything complicated, but design an information system for your agents. First, context isolation means giving AI only the information it needs for the job at hand. Nothing more, nothing less. So it can perform reliably, safely, and clearly, just like manage a team. You don't mix legal review, creative writing, and customer support in one meeting. Each role gets its own focus and rules. Same logic apply here. Split your task into separate agent or session based on functionality. Define one clear goal per agent. Remove related information and reset context between jobs. Second, dynamic loading means give the AI information only when it becomes relevant instead of give everything upfront. Dynamic loading is about timing, not technology. It prevents overload and improves clarity. Think of a business trip. You don't carry your entire wardrobe. Bring every document you own. Pack for every possible scenario. Instead, you bring what you need for the trip and add or request more only if plans changes. Same with agent. Practical tips. Store project brand information externally. Have a folder structure with a clear index. Define clear rule in skills and agent markdown file when information needed to be loaded. Sometimes it is better for one conversation only to solve one bug. In that way, you were able to reduce the token consumption, have agent focus sharp, improve execution, reaction time, and accuracy. Remember, more context doesn't mean better performance. Better context does. Clear, focus, timing, that's make agent work. Lesson number 4. Agent memory is about visibility, not storage. Most people think AI memory is just a digital filing cabinet. Store everything, remember everything forever. In practice, agents don't have one memory, they have different types of memory, serving different purpose. To keep it simple, think in 2 categories. Internal memory, this to be used inside within a single run or conversation, like working memory or messaging passing from one agent to another. This message is disposable. Once task or conversation end, it's gone. While the external memory is a long term. It holds information that must remain stable over time, like project background, policy, brand guidelines, reference document, like Markdown, PDF, code file, or anything you should stay consistent across agents and sessions. A good analogy is ChatGPT project. The system prompt and the project file are long-term memory. Each individual chat is short-term memory. When you close the chat, the context disappears. Problems start when we mix them up. Another common mistake is assuming the agent can safely summarize and passing information forever. But it can't, because large language models are probabilistic. Every time information is summarized, rewritten, or passed along, it drifts. That's why examples often work better than rule for instructing AI. This connects directly to the previous point, context engineering. If something must be remain unchanged, like legal text, source code, don't pass it through agent repeatedly. That's expensive and unreliable. What you should do instead is decide what belongs in internal memory and what belongs to external memory. Keep long-term reference in storage, not in conversation. Keep reference or link, not raw text when precision matters. Let agent read from the same source of truth instead of passing information. Use example for behavior and rules boundary. Remember, AI agents don't have one memory. They have several very different ones. Confuse them and the performance will degrade. Design them intentionally and consistency improves. Lesson number 5. Always set midpoints for checking. Trust but verify. The most dangerous moment in AI development is when your agent finally works. It's running end-to-end, but then it gives you a perfect reasoned answer that is completely wrong. They can have technical correct in their logic, but fail because they consumed bad data from a search engine and outdated API. That's just one of the examples. In business, that's risk you can't afford. If you're building AI system for real-world use, review isn't optional, it's required by design. 3 practical tips can help. First, insert review mechanism. Always treat external data as uncertainty. Mature systems use a second API call or a reasoning step to validate, summarize, and check the fact before the agent uses them in a final output. Second, use predefined skill for depth. If you need an agent to perform a long, methodic task, like a 20-page market analysis, don't let it improvise every step. Instead, give it predefined execute template or say skills. This provides discipline of traditional workflow with flexibility of an AI. Here is the video about agent skills. You may check it out. 3. Logging is functional. Once your agent stack or system gets complicated, debugging output is useless. You must log every step, every tool call, token usage, context actually consumed. Only by replaying execution trees, you can improve speed, cost, success rate. The bottom line, if you want your agent to be trustworthy, build in checkpoint. Don't just test the final result once, test how it got there. So those are the 5 lessons I wish every business leader knew before building AI agents and the AI agent system. Prompts alone won't save you. Elegant architecture can actually make things worse. Context and memory need to be designed, not dumped in. And trust but verify is not a nice to have, but the core to reliability. Building effective AI agents is not being more technical. It's about think clearly, start simple, design for real workflows, and add structure when the result demanded. Iterate, iterate, iterate. If this video inspired you, Like this video and share it with someone you think needed this. Subscribe if you want more practical, non-hype content using AI. Comment below. What's the one lesson you are going to apply first in your own AI projects? Thank you for watching and see you in the next one.